Okay, hello class. Alright, so today we're going to talk about properties of real numbers. To get us started thinking about how numbers work, I have this problem for us. So here I want us to add a bunch of numbers. And I want us to do it without a calculator because otherwise it'd be too easy. Alright, so if you want, I know by now some of you guys are already doing it, and you're probably doing it the way that you've been taught, which is using the order operations, which is a very good way of doing it. But, it's not the best way if you try and do it in your head, because normally according to order operations, go from left to right, because all we're doing is adding. So you do 3 plus 9, which is 12, and then you would add the 4, which is, 13, then you add the 2, then the 7, then the 1, then the 6, then the 8, and then you get your answer. But it's, not the easiest thing to do in your head. And it's not very fast. And so when you have all addition, there's actually another way of doing it. And we're going to do it by using grouping. And one of the powerful ways is we can use groups of 10. Because it's very easy to count by 10. So what I'm going to do is I'm going to look at groups of 10. So I can combine, for example, this 3 and 7. So 3 plus 7. Well, that's one group of 10. And so I use them. I'm going to cross it out. We have this 9 plus the 1. So all I'm doing is I'm just reordering the numbers, right? Then we have this 4 and the 6. That's also another set of numbers I can add up to 10. Then lastly, we have this 2 and 8. So I've used every number here, but now we have it in groups, right? This group adds up to 10. This group adds up to 10. This group adds up to 10. And this group adds up to 10. So very quickly you can see that all these numbers we had in the beginning really add up to 40. And I can do that in my head or on paper really fast. But the way it was written originally made it really hard. So by grouping the numbers in a different order, I'm able to get the answer fast. And so the question, of course, is when can we change things versus when can't we? And so right now, today, we're going to talk about the properties of a number. So we're going to discuss potentially the situations in which you can change the order of things and you won't change the value. So you get the same answer, but potentially you can make your life a little easier, and potentially when can't you? And so to start, we're going to talk about properties of real numbers. So these properties work in all situations, right? So no matter whether we're talking about numerical expressions or algebraic expressions, they always work. So the first one we're going to talk about, pull up here, is something called, you guys have heard before, is called the commutative property of addition and multiplication. So addition and multiplication tend to be our friends. They're easier, they tend to work well, and they tend to have a lot of properties that make things go so much easier. And so commutative property of addition and multiplication says that if I change the order, the value of the expression is the same. So for addition, a plus b is the same as b plus a. An example I gave here was 18 plus 54 is the same as 54 plus 18. And if you guys did the math, you know that is true, right? 18 plus 54 is the same as 54 plus 18. So that's actually true. And the same thing works for multiplication, right? A times b is the same as b times a. And then here, another example here is 12 times a half, which is 6. It's the same as a half times 6, which is 12. So once again, it doesn't matter which I do first. And so the commutative property basically says as long as I'm doing all addition or all multiplication, if I switch to order does not matter. So order does not matter. Alright, that's what commutative property says. Now here we have another property which also says basically the same thing, which once again, order does not matter. And so this is the associative property. And all this one does is it involves parentheses. And once again, it involves our two favorite properties, addition and subtraction. Addition and multiplication. My bad. So for addition, I'm adding two numbers in the parentheses, which means according to order operations, I would do that first, and then I would then add the number outside. And they're saying, well, if you take this parentheses and then move it, so from the first two numbers to the last two numbers, so that I would do these two first according to order operations, and then add the last number, I get the exact same value. And it says the same thing's true for multiplication. So to test it, I have this over here. So over here, according to order operations, if I'm doing addition, I should do 23 plus 9 first, and then take the answer and add 4. So if I do 23 plus 9, I get 32. And then 32 plus 4 is 36. Okay, not bad. And over here, I'm doing 9 plus 4, according to order operations, which gives me 13. And then 23 plus 13 is also 36. So it's actually true. And then if I did this multiplication, oof, this is hard for me to do in my head. 7 times 9 is 36, times 10 is 630. And they're saying now if I were to change, if I just move the parentheses from the first two numbers to the last two numbers, that the value doesn't change. So let's see. 9 times 10 is 90, times 10, times 7. Yep, same answer. So I've gotten equivalent answers. Alright, so these are the two main properties that I think are used the most, in which once again the associative property says that order does not matter. Alright. Now, these are lesser known properties, but, well, lesser known, I should say lesser important properties. Properties that you guys probably know. I wanted to quickly just cover and mention it. But you guys should have to know it. So eventually when we generate a vocabulary list, you guys will have to write them down and memorize them and know them. So if it's worth spending a quick minute to study them, and we should go over them quickly now, is a couple properties called identity properties. So when I look at density, I think of the word mirror. Right? All you guys who love your selfies, right, the mirror property. And so, for example, you think of addition. Well, how do you get addition? Well, if you have a number and you want to get the exact same number back, well, what do? You add 0 to it, right? So, it's like looking in the mirror. A plus nothing is A, right? And the example I gave of numbers, right, a number plus 0 is still that same exact number. But for multiplication, the mirror is a little bit different, right? So when you're multiplying, you don't multiply by 0, you multiply by 1. So any number times that mirror, 1, is that same number again. And once again, here's the numerical example. Alright? So the density, or my mirror property, right? And once again, this works only for addition or multiplication. And then next two properties we have are the zero property of multiplication. So yes, I will have to actually memorize that long expression. So the zero property of multiplication says that any number times 0 is just 0. Once again, you guys know that pretty much already. Any number times 0 is 0. So 18 times 0 is 0. 10 million times 0 is 0. Any number times 0 is 0. Right? And then lastly, the multiplication property of -1. -1 times a number is just the negative version of that answer. Alright. So very quickly, I just wanted to know. So we've been talking a lot about multiplication and addition. And I want to take a quick second just to think about subtraction. So I want you guys to think about this statement for a second. And then answer it. And then we'll go over it in a second. So here it is. Is the statement true? For all real numbers, is A minus B the same as B minus A? Get an answer. Got it? Alright, so let's look at it. So the answer of this question is no. And to show that it's not true, I'm going to give you an example. And the example I'm going to give you is this. 5 minus 3. And that's going to be 2. Now if I were to switch it, so in this case A is 5 and B is 3. If I were to switch it, I'm going to get 3 minus 5. And if I switch it, that's not the same. 3 minus 5 is negative 2. So I can say that these two are not equal. Right? Because one is positive and 1 is negative. So what I just did is I came up with a counter example. And what a counter example is an example that shows a statement to be false or incorrect, right? So we just showed that basically this property, which would be the commutative property, is not true for subtraction. Right, perfect. All right, so now that you have all these properties and you guys take a quick minute, memorize them, study them, I'm going to ask you guys to do two things with these properties. I'm going to ask you first to be able to identify them. So looking at a statement, you'll be able to know what type of property it is. And the second thing I'm going to ask you guys to do is I'm going to ask you guys to be able to use these properties in some sort of mathematical context. So now I'm going to quickly just do a couple examples to just basically show you what I'm going to ask you guys to do with these problems. So for the first one, problem 1, I'm going to ask you to simply identify the property. So take a quick second, see if you can answer these 3 questions by yourselves. Got it? Alright. So hopefully you've attempted yourself. If you haven't, shame on you. But let's go over to it either way. So this first one, which property are we going to use? Well, I'm doing a number times 0 is 0. Well, that's definitely true. Well, I'm noticing a big fat 0. So for this one, it's obviously going to be the 0 property of multiplication. Right? Easy one for that one. Now for this one, I have a number plus 2.5 plus 28. And then over here, well, let's see, I'm trying to go change it. What happens is, seems to be the parentheses moves from the first 2 numbers to the last 2 numbers. So according to PEMDAS, I would add, instead of adding these 2 first, I add these 2 first. Well, that's a clear associative property. And since all I'm doing is adding, it's associative property of addition. Alright. Now for this one, I have some expression, 10x, and I'm adding it to nothing. So, and I get just 10x back. So that is totally for you vain people who love your selfies, right? When you look in the mirror, you get just what you look at, right? Or you take a picture of yourself, you get just yourself, right? So that is my clear example of the identity property. And since we're adding, let's have addition. Alright, so please memorize those properties. Alright, so now this is the tough part. So now let's actually use these properties. So I'm going to rewrite an equivalent expression. So equivalent expression means an expression that has the exact same value for all possible values. And honestly, I'm going to show you, you'll see. So for this one, 5 times 3n. They want to simplify this expression. So we can use the properties we just finished going over to simplify this expression. Right? And so according to the associative property, see how parentheses, first off, it knows I'm multiplying everything, right? Multiply, multiply, right? So I'm 2 multiplications. So according to the associative property, I can move the parentheses around these two terms and move it to these 2 terms. So I'm going to first and foremost, it's going to equal to, I can move it to this way. I'm just going to move the parentheses over. And that's because I can use my associative property. of, I'm going to do m for multiplication just to make time short. And then obviously we know what 5 times 3 is 15, and we get the answer of 15n. And so associative property is the reason why we can write this. Now, when it comes, later down the line, honestly, am I going to ask you guys to do associative property? No. I'll be happy that you guys know that 5 times 3n is just 15n, right? This is where I want you guys to be at, ultimately. But knowing that the associative property is the reason why it works is helpful. All right, let's try this one now. So for this one over here, once again, I want to simplify this expression. So for this one, once again, I'm going to show you, how we can do it using the textbook way of doing it, and then honestly, how I want you to actually just get the answer. So since we're just practicing using the properties, first thing I'm going to do is, I know I want to combine like terms, but this like term's on the left-hand side, and this like term's on the right-hand side, so they're not very helpful. So first thing I'm going to do is I'm going to switch the two terms so that these two are swapped places. So if I swap the two terms, like I'm adding them, that's called my commutative property. Of addition, so A for short, I'm running out of time. And then, now I have all addition, right? Notice? But now I want to add these two terms. I want to put them in the same parentheses. So I'm going to simply move the parentheses around the two terms that I want. Notice I'm adding everything. That's my associative property. And then lastly, because they're now the like terms, I can add them. And I simplify this expression as much as possible. Now, once again, ultimately, you guys have been doing algebra for a while now. I'll be happy if you guys notice the like terms, combine them, and then just go straight to here, and I'm okay with that too. Right? Now for this one's a complex one. I'll show you, but once again, there's the easy way, which is just, the way you guys have been doing it probably for years, and then the way that the properties really explain why you can do it. Right? So right now we're kind of going like peering behind the curtain, explaining why it works. So for this one, it's a little bit weird. You can kind of work backwards. So I'm going to use the identity property in reverse. Right, using density property of multiplication, because we know that 1 times any number is just 1 times any number is just a number, so I can write it as 1y, same as just writing as y. Right, and then so I can now split the fraction up. It's legal. Right, I'm just kind of separating it. And then once I have that, I can simplify. 6x divided by 1 is 6. Y divided by y is 1. Any number divided by itself is always 1. And then lastly, if I use the identity property again, I get 6x. Alright, so all this hot mess. Now, once again, on test day, what I actually expect you guys to do. Let's be practical. What I will notice you guys to do is that most of you guys will notice that the old school ways that you had a y. Noticing that 1 is there is pretty smart. So I'd probably put a 1 there just to be safe. It's nice to have a number in front of the variable, or coefficient is what's called. cross out the y's, one y on top, one y on bottom. They cross out because, once again, y divided by y is just 1. But most of you guys use just crossing it out. So I'm left with 6x over 1, which is just 6x. And that's the way you guys usually do it, right? Without having to write all the properties down over here. So in this case, what we just finished doing is we just finished writing something called equivalent expressions. And so they're expressions that have the same value for all values of the variable. Oops. Algebraic expressions that have the same value for all values of the variable. So what does that mean? So for example, if I go over here at this expression, we originally had this 5 parentheses 3n, and we rewrote it as 15n. That means if I would take any number and would have plugged in, this expression would be the same as this. For example, let's say I plugged in my favorite number 2 here. I would get 3 times 2, which is 6, and then 6 times 5, which is 30. And over here, if I plug the same number 2 in here, I get 2 times 5, which is actually 30. But if I took any number, whatever, if I made any number I want to, this expression would be the exact same thing as this expression. So these two are known as equivalent, aka equal expressions. AKA stands for also known as. So equivalent also means equal. So they are equal expressions because I can plug in any number I want to. On the left hand side, these two expressions will always be the same. And it's true here. This expression is equal to this expression. And this complex fraction expression, if I reduce it, it's the same as this expression. Alright, that's it. Take care.